Hello everyone. I haven't done any new projects lately. I've been doing a lot of upgrades to my old stuff. A lot of my software I've been fixing, uh, poorly written software fixing, and one of the projects, my dual motor driver, I'm planning to make it do something better. I don't know if anybody saw my what did I call it? A trig plotter, where it was driven by this. It was very slow and cumbersome. So what I'm trying to do is upgrade this firmware on here so that these motors will rotate at a set speed. Although that they moved at a set speed before, it was just controlled by the pulse width modulation from the output of the microcontroller. But actually I want it to control the speed at an actual time based speed. So I want to be able to control the actual RPM, so that they actually turn, the motor actually runs at a set RPM. This way I can create a time, an RPM, where both motors will move to a certain position at a given rate and arrive at the same destination at the same time, basically. So showing you the code is a bit boring, really, but I just thought I'd do a demo. And one of the other things that I've been working on is, like I say, software, and what I've done now, I've put the software on Microsoft Store now. So if we go to Microsoft Store, to my page, I've done the new pixel rule as well. Sorry, no, the big pointer. I've put this on Microsoft Store, so you can now actually use this as well. So let me just start that up. If I remember where I put it. Oh, I haven't moved it to the thing. Hang on, just give me a moment, guys. Because it'll end up in apps, and then I need to actually put it on my start menu. Yeah, there we go. So yeah, I've got this little app. Forget about the pixel rule. This pixel rule is just like a ruler that I can measure pixels. I can move it around. I can go step it by a pixel at a time, like this. But this is for another project I'm doing, where if I'm placing things on, I use Leaflet as a map, um, one of my programs, and I like to put overlays on the map, and I want to measure the distance. So if I can choose which corner I want to measure from by selecting this, and then I'll put that corner on to something to measure. Say if I'm measuring that, and if I want to measure the length of this, I can click here, and then that'll give me, hang on, click that corner, shall I say, first. If I click here, there, I can see that it's 192 pixels. So yeah, forget about that. That's a tool I've got for me. So I'll just close that. But a big pointer, yeah. So this is my hand, and it now sticks to the mouse. I don't have to drag it. And if I click my middle mouse button like that, I can actually rotate it to where I want. Then click the mouse button again, middle mouse button again, and it'll stay at that angle. So now I can point to things. So the other thing I've done is my serial monitor as well. I put this on Microsoft Store, so I'm going to open that one up. There's other projects. I've done this one as well, and I'm sure I've shown this on my Instructables, my digital thing, and these are all ones I've done before as well. So let's have a look at my serial monitor, because I'm going to use that to actually control this this stepper motor. The motor driver, dual motor driver. So let me see on a monitor. And here's my new serial monitor. I'll just move that out of the way. So yes, oh, it's not plugged in. So let's just put some. Just drag that out of the way. So now what I'll do is we communicate with this through I2C, and to communicate with that through I2C from my USB, I have. Let's have a look. See over it. Will it reach? I've got my Arduino down here, which has got the. Can we see that? Oh, wrong one. There, my Arduino. I've got I2C coming out of that, and I'll just plug in the USB. So that's that started up, and now we should have power to my thing. I'm going to have to reduce the brightness there, I think. And so now I can talk to that. So basically, it's got some. So now I can find it on port 17 and connect. We're connected. Yeah. Changes I've made. I can make this bigger now and smaller so that we can see what's going on. And also, what I've added to this is these are presets we can keep instead of typing it in down here all the time. What I can do is put presets in here and select them. So I could select that. Just go select, and it'll put the text in there, and then we can send it. Well, what we want is the X, because my software that I've written talks to it. So to find out what state this driver's in, we can use the X command, because that's what I've written in the Arduino code, in my Arduino down here. It will ask it what settings have you got and everything, and that'll come back and reply to my Arduino, and then my Arduino will display it on here when I send the command X. So we'll just send that, and there we go. So we can see the current position is -3, -1. Now what I've done is, you can see that I've written 30 here. That's because it's got 30 slots. The way my motor driver counts the encoder is quadratic. That means for every slot on here, every 30 slots, there's actually 4 states. So we can actually, every time it moves a slot, it actually moves 4 positions. So if I was to just, this is motor A, which is this one here, right? So if I just gradually turn that around, it's sort of moved a little bit, but what we'll see is that this is quite a big change. So if I ask it again and send what position is the motor, we can see that it's now at -13. If I can just move it back, I don't know how far I moved it, and then send again. Well, that was a good guess, wasn't it? We're at -1. So I didn't really move it that far. So in actual fact, one full revolution is there. That is 4 times 30, which is 120. So we got our 30 here. If I was to move that one full revolution, let's go all the way around. I think we're about there, won't we? That should be about 120 then, shouldn't it? Oh, 118. Just give it a little bit more of a turn. Oh, 119. A bit more. Oh, I might have gone too far. Oh no, it's still at 119. Shaky hands, it went back, didn't it? Come on. No, 122. Right. Ah, well, close enough. Anyways, so you can see that one full turn is 119. And because I've got 30 slots in there, I now actually tell it that I have actually got 30 slots. So my encoder A slot count is 30 here. I mean encoder for the B count is 30. So I've got another motor. Oops. Got another motor here as well, sort of thing. So 2 motors. Can I move that across a bit and get that? So we can, you can see all that now. And I can bring this back in again. Let's make it a bit narrower. Oh no, it's as narrow as I can make it. So you can see both motors. So what I can do is actually I can, the M command, we've got M1 for this motor, and we've got M2 for this motor, and we've got M3 for both motors. So what I can actually do is send motor 1 at 100 RPM to position position 2000. Now 2000 is one of these counts on here, so when you're writing the firmware, you work out how many counts you've got on a motor and how many counts it takes to go 1 millimeter, and then you can do your calculation and how far you need to move. But anyway, so I've made it the counts of the encoder, because obviously then you can actually add whatever encoder you have, and you just have to tell it what slot count you have, basically. So if I send that, if I send motor 1 to position 20,000, and I'll send motor 2 to minus 20,000. So I'll just select that. Well, turn power on before I forget. I haven't turned my power supply on. Right, there we go. Right, yes. You can see, oh yeah, and so my new board as well, it's got 2 LED, there's actually 2 LEDs there. One indicates power to each motor, and I've got wires coming in for each motor, basically. They're both the same. Right, so now I've got power, we can actually tell it to move, so I'll go for this one, send that, and that you can see this one is actually turning clockwise, and if I send this one, send that one, you can see this one is actually rotating anti-clockwise. Now it's going very slow, but that's because I've set it at the speed at 100 RPM. Let's change the speed to 800 for both motors, so I'll speed both motors up. So if I select that, and now you can see that they're actually both running a lot faster. So you can see that we can send commands to each motor individually. Let's try X again just to see what the current is, and there, so we're within 11 ticks. Now you have to remember 11 ticks will be maybe 3 of these ticks on there, so you're actually only moving it sort of, it's only out by 1, 2 and a bit. Have I gone the right way? No, I went the wrong way, didn't I? So if I go back to where we were, and then go 1, 2 and 3, that's about right. There, so like 204, maybe just one more, 201. So it wasn't actually out, and obviously you're going to have gearing on your motors as well. So that amount of accuracy is really pretty good. Obviously, if there is your encoder only has 4 slots on it, you may get it even better, because the overrun is even less. Yeah, so we can see that one's at minus 20,000, one's at, but we can actually send a command to both. So what I'll do is I'll send them both to position 0 at 1000 RPM for both motors, because M3 is that. So I'll select that and click send, and you can see that they're both going, and they're both going at 1000 RPM. So that means they should both end up at the same place at the same time. It's not relying on roughly the pulse width modulation, it's actually turning at RPM. So that's my improvement to my motor driver. So using these variables that we've got now, I should be able to send commands to actually control both motors at the same time without having to step small increments. I can move one large increment, knowing how long each motor is going to take to get to the position that I want each motor at. And so I'm going to try putting these into my trig plotter, rewrite code for the trig plotter, so it should be able to draw lines a lot faster now. Right, yeah, so that was my update. So I've updated my motor driver. Oh yeah, and I put all the information onto my GitHub. Where are we? Yeah, so you can get the serial monitor now on Microsoft Store. That's not. So I've started putting stuff on Microsoft Store so that you don't have to worry about is this safe to install and all that crap that you used to get. Windows used to bring up the blue screen. This is not a known software, so it now gets rid of all that. But yes, so my board can be got from my projects page on PCBWay. I've gone through what it can actually do. Now this is all the original, so the commands, these commands will be for the old firmware. I've changed these. This has all changed now, so they've gone, and it's changed to like a basic command. So what I'll do is I'll get rid of that, and best place to go is to my GitHub. So in my Git, let's just go. Right, yeah. So we're on the main page. So we've got it all here, and this is exactly the same stuff, where all the commands there are for the original firmware. Like I say, these have all gone. Oh yeah, and these have all gone. It's now a basic command, and what I've done is, depending on the firmware that you install, so if we go up to code here, oh yeah, I've got the original firmware. So the original firmware is in there, which is that's for the tracks in the video of my little machine, little robot thing, and this is the Arduino test, and this is a zip of the actual code. I don't think I actually zipped it up when I've done the other one. Let's have a look. Yeah, so the latest for version 2 board, version 3 firmware is this one, and I've put down the changes. So I've gone for this standard letter sort of thing. It's just a rule of thumb that I like to do. It helps me remember what value I'm putting in the command. And so now we have the basic commands. We don't have the forward and reverse, the F and R. We just have a B not stop, B1 forward, and B. Oh, I can show you that as well. So all that, these actually don't. The basic commands are just for, say you've got a robot with no encoder and you just want to set the speed through pulse width modulation. Let me just move this out of the way. So like I've got a B command here, B2, which is reverse, which is B2 is a reverse, and at a speed of 500, and both motors. Now the 500 isn't RPM this time. With the B command, the RPM is pulse width modulation, which is a value between 1 and 1000. So this is basically 50% pulse width modulation. If we select that, you can see that they spin a hell of a lot faster. They're going more than 1000 RPM. And if I actually change the speed, that we had 500 there, this is 80%. So I'll just select that and change the speed. I don't know if you can hear the motors. but they are now wanging on now. So, and if I change that down to say 2, you can see that they've actually slowed down. But that's for the basic movements. And then BO is stop. So we just select that and stop, and it stops them both. Or you can just send one going. If I went with this, select that, and I just change that to motor 1. On motor 1, only this one should move. And there you go. And let's just stop that. And if I do an X now, you'll see that the position it was knocking on a bit in reverse there, so it will take forever for them to come back. So let's just bring these back to 0 at 1000. You see, at 1000 RPM it's a lot slower than using the pulse width modulation. You can trick this by altering your encoder count. You can make it think it needs to do 60 per revolution. That'll double up your revolution. Right, so yeah, back to my GitHub. So yeah, I've done the new codes for the new software there, so everything's changed, and I've given you an example of Arduino code. And the firmware is actually in there, so yeah, it's the 3 files. This is the actual firmware, this is the options byte for the microcontroller. It's a bit like BIOS on a PC sort of thing. And this is the data memory. This sets the memory values for when you're setting the settings. Like see all these settings, they're all saved to the EEPROM. So they're all saved on the EEPROM part of the flash. Yes, so yeah, that's my firmware. So yeah, so it's all on my GitHub. You can get to all my stuff basically from my home page, GitHub, repositories, down. Where are we? Have I passed it? I don't know. Passed it, didn't I? No, is that it there? I can't remember. It should have version 2 on it. Anyway. Oh, dual motor driver. No, that's the old one. Superseded that one. Oh, it is the new one now. Oh no, that's to my thing. Oh, I can't even navigate my own page. Oh dear, 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 dear. Where's the version 2 then? Oh, it's right at the seat, right at the top. It moved it. It must be because I've just been looking at it. I thought it was further down. Is that it? That right? Yeah. God, why have I put S19 here? Have I put S19 there as well? Oh yeah, I must. Oh, mind you, I don't think that should have been there. But anyway, code latest original. That's the one. Anyways, right, what was I saying? Yes, so yeah, I've upgraded this as well. Oh, right, that's it. That's about all of it, really. Oh no, there's one more. I think. Did I do it? What have I done? Let's go to my home page. Oh no, I've already got it up. Hang on. Where are we? Home page, Microsoft Store. Have I done? Oh, I haven't done it yet. I've been working on another one as well. I'm working on my plotter program. It's still to come on Microsoft Store. Where are we? Yeah, it's not there. What I've still to do is this one. This one where you can load G-code and send it G-code to my plotter laser or whatever I want. Right, so yeah, so I haven't done that one yet. That's still to do. But that's the reason why I haven't done any new projects lately, is because I'm sort of going through my old stuff and I'm putting it onto Microsoft Store so people can actually use it. I'm sure I've done a video of this using a little pixel editor. Yeah. Oh, right, well, okay, that was just a fill-in because I haven't done anything for a long time. Stay tuned. Hopefully I'll come up with a new project, something more exciting than this. Catch you later, guys.